Good evening. Good evening, sir.
Hey, Ottilie, I need, half a second. I need to change my headset. Hold on a minute, please.
Sir, good evening. I wasn't hearing you just now. Hello?
Hey, Ottilie, how you doing?
Okay, so far, sir.
All
I was
right.
speaking, but wasn't hearing.
Right. You heard what I was saying to you earlier?
No, that's what I was saying. I came in, opened the mic, but when I
Mhm.
opened the mic, I wasn't hearing anything. So yeah.
Oh, okay, okay. All right. Hmm. All right. There are what I could do. What I could do with you. Hold on a minute, please.
Okay.
All right. You actually went through calculus 2 before, Ottilie?
I started, sir, but remember I had discussed with you that I had to come out of the
Yeah,
class.
man. I get
started,
that. Hold
yeah.
on. No, that's not what I'm asking. I'm asking, did you ever do the whole course at any point in time before?
No, sir.
Okay. All right. Got you. And you got through calculus 1, right?
Calculus 1, I got a D plus.
So, actually, I don't believe you.
We don't know, sir, but
No, hold on. So you still
um,
have a D plus a calculus 1?
that's what I saw on the grade. I don't see anything. I don't.
So why didn't
Ask,
you do the calculus 1 in last semester?
I couldn't do it. I couldn't do it on the day because work changed and I had to work every Saturday. I wanted to do the 1:30 class and it couldn't work because I didn't want to go ahead. Yeah. But what I was doing is going through the paper. I think I'm gonna come up on my result them. Because I think the last update, me see, the last grade that I saw.
I never know that. It's just by chance I'm asking you.
Hold on, sir. Let me go in there.
But utterly, let me ask you now. The conversation that we had before, I mean, you literally said you're trying to finish off
Sir,
in the
I
summer
don't
semester.
know. Yes.
Oh, you're going to finish off in the summer with a B plus in a
Sir, I
calculation?
don't know what happened, you know. But me could assure you we pass
Never
the
beat you.
exam.
Never beat you. Never beat you. Never put you across my lap. I'm never beat you.
Sir, honestly, is it even the stationary point? It's like I'm going to exam.
No,
Me
that's
a
fine,
practice.
Okay, yeah, that's fine, I'm just saying what I'm surprised about and slightly annoyed about people is the fact that if I had known that is a details that you have for the stuff, what I would have done is to somehow get you to do the exam last semester, the semester that just went. Because I had a group of
Yeah,
students
I
using
had
that
spoke to
classroom.
Miss what because when all right, so what I did last semester when I found out that I would not be able to, I can't finish this summer because what I want, they're not offering project management. So I have to go back September to do project management. So what I told Miss Campbell I would do, I said, all right, school graduation is February. So I told her, all right, Miss Campbell, I'm gonna leave calculus 1 exam till September because I'd have from September to January to finish off because exam is, graduation is not until February.
How you
So
know the graduation is going to be February?
That's what I heard.
Oh, okay.
The guys in the group told me. Some of the guys in the year 4
yeah,
told
but
me that.
graduation was in February because of COVID. No, we're past COVID situation. Hold on a minute, please.
Okay.
All right, utterly.
Yes, sir.
So what I would recommend for you to do utterly is so since you have I can't guarantee that the graduation is going to be in February because that was COVID arrangements.
Okay.
what I think though is, all right. Don't worry about it, because since you say you have project management to do, it's just that I know the conversation that we had, you did say to me that you're finishing up in the summer.
That's what I wanted to do. But then when I went into what the courses are, so when I sit down and I looked at what was left to be done last semester and this semester, and I kind of was, you know, researching on what is going to be, which of the courses will be offered, I would have realized that, hey, it's not going to happen. Whereas the courses that I want to do, they'll be clashing, because why I wasn't able to do calculus 2 is because I was clashing with networking, advanced network. So, and that was not being offered again for this semester. So I said, okay, since sir said there's a fast track class, I'm gonna try to fit into that. I couldn't fit into it because I had work now all day on Saturdays because I have to be cutting up sometime within the week for school. And then I had major project capstone started, work experience, and a whole lot of other stuff doing. So I had to say, I don't want to fail the course. So it doesn't make sense. I just pack up everything on myself. I know that I can't manage so much. So just leave it. I don't like, for this semester, I don't have a lot doing. So when the semester come, I can just focus and put a lot of time in Cal to ensure I pass it. So that was the kind of idea behind choosing to do it like no and not last semester.
All right, I hear you. I hear you absolutely. All right. All right. So, my only challenge for this group now, will be the numbers. So you recognize that you're the only one here. It is timetabled.
Okay.
There are a number of students who.
Sorry, sir. A lot of persons didn't do, the rest of persons didn't do the fast track.
Which one?
Calculus 1 fast track.
Some students in it, I think it's about, in total, about 8 students that did it.
Okay.
But I can say to you that the calculus grades from last semester never looked so promising. So I have not even submitted it just yet. So maybe because it's me not submit those grades yet. I mean, I finished mark them, you know. This means don't submit those grades. I finished mark the exams, that is. Me not submitting the grades. People don't know, you know, them status. But the thing about it is that, as I told Mrs. Campbell, I shame about it. I mean, I've been in meetings all of this week with her, and have been making reference to because we're discussing exam results for students and how poor they are generally.
Wow.
I shame, you know, for the team here. When I say shame, I'm really shame bad.
Sir, I think for most, well, for me, I think really and truly, the academic advisement is really to be stressed on, because when you don't get the academic advisement, for me, courses that I fail, I first me fail one course 2 times. As a matter of fact, from start school, I second course me ever fail, and me get really good grades. But math have always been a challenge for me. It's not you know, my best point. But you know, when you take up the courses and you think that you're able to manage them, and you don't realize, so especially with IT, when you're doing the programming languages, what happened to me when I did the Cal 1 again, I was doing PHP in the morning, in the morning time, and I was doing your class in the evening and 4 other courses. So for that semester, I was doing 5 courses.
Too many courses.
Too many, right?
Too many courses.
And so I had in the end of it, I was putting a lot into PHP, into ASP.NET and practicing for that exam mostly. So I realized when you have a programming language to do, do not choose maths. Don't choose maths, because it's not it might be feasible for people who have a lot of time, but not for people who work and do long hours either. So I think academical advisement, because when I spoke to Mr. Rose, yeah, and he was like saying, all right, do this, don't do that, and do that and that. And I said, okay, well, all right, cool. And we work with that, and it's kind of better procedure. So I think a lot of us, we just jump into it, and we're just doing it. And when the workload come up on us, then we realize that, hey, whoa, this is hard.
Yeah, and I think that is a problem. People were just not taking the classes very seriously. One of the things that I am a little disappointed about is I will come to class and I will say to the class, say it happened in calculus 1, it happened in calculus 2. I'll come to class and I say, listen to me, stationary points is a staple on the exam. You must get a question on stationary points. Calculus 1, it is going to be on single variable functions. Calculus 2 is going to be on multivariable functions. And I go through stationary points, I go through stationary points, and I go through stationary points. And when I go into the exam for calculus 1, calculus 2, nobody got 20 out of 20 questions. And as I was saying in one of the exit meetings yesterday, when I was going to school, teacher can't play them joke there with me. So I'm expecting, and I understand the variables that people work and people have this and people have that. But when I went, my undergraduate degree was the only one that I went to school full time for, and not for the duration of it. My first year was life, total life. I worked when I was going to school. I worked full time. I mean, I went to school full time and I worked part time, because I remember when I finished A levels, I got a summer job. And they wanted to keep me on, and I said to them no. And when I got another job, I got another part-time job. But I'm going to tell you, after my first degree, everything else was me working full time, and one of the programs me going to school full time, because it was only offered full time. And you had to put in a lot of work. And this is what I believe is missing. I understand that you're working and you have children and you have husband and you have wife and the whole stuff, and and drive and have to take the bus, and I understand all of that, because some of those variables too I had to deal with. But guess what? I know when I come home from school, 9 o'clock class done, or sometimes 8:30, depending on what. I remember I had a 47 class on a Friday. And when I like to, when I come home sometimes 8 o'clock, 8:30 on a Friday, me no want to see nobody. Me bed, I'm going to bed. And guess what? I recognize that there's a lot of work to be done. When we go to bed at daytime, weekday, I would have to get up like 1 o'clock or 2 o'clock just to put in some work so I can stay afloat. So part of the problem, yes, you hit the nail on the head. We spoke about it. Maybe students are carrying too many courses. But another part of the problem is students are just not committing to studying, because there's no way I can give you a question in class and that very question is repeated on the exam, and everybody in the class won't get 20 out of 20. You have students in the class that get 0 out of 20. And the question is repeated, and the teacher go through that same question in the class. Teacher can't play them games with me. Not even know. Teacher can't play them games with me. Can't happen. So I think people are not committed to doing the work. No. The class is small. The semester is short.
Yes.
I have committed myself to this already, because in the meeting yesterday, they're saying that the class size is not 15, we can't run the course. And I messaged Mrs. Campbell, said, Mrs. Campbell, what happened? And she said, we should be able to find those. And I said, all right. As it is just now, I'm seeing somebody that's joined the class. Good afternoon, Miss. You just come to the teacher class. I'm just don't say auditor teacher. I'm not understanding.
Sir, I said something, but you didn't respond. I came in earlier.
Oh, never hear love. How you do?
Fine, sir.
Incidentally, I was going to call you because I remembered you and your situation. So I actually was going to call you. Like I did awfully today. So I know Shani is supposed to be a part of this group, and I should have one other student. I know for a fact that will be 4 plus. No, not one other student, 2 other students. So that would be 3, I would have 5. So I'm thinking that I can get the 10, the minimum 10.
Sir,
Go ahead.
a question. Remember, I started it last semester, so I would have completed some of the work. Some of the
If you ever tell me, say, you did some work on Edison before and you can just continue from there, I'll tell you the whole of that gone. No, because remember, you know, it's a new semester.
A new semester.
Yeah, and then what happened is I will have to every semester I have to request a new loading from Edison.
New thing.
Yeah.
Okay.
So I don't have access to that again. That's just the fun. All right. So let me sort myself out. Give me 2 minutes. When I go get myself ready, drink some tea and get myself ready. Use bathroom and all the work. And give me about 3 minutes and I come back to you. All right?
No problem, sir.
Cool. All right, it's okay. All right, so I'm here thinking, what can I do to get you guys? All right, so I know Nesta is, I know the pair of you, both yourself and Nesta actually are a little afraid of the math. And the pair of you will have to commit to me in getting through this course. My teaching strategy will have to be different. To get you guys to the point that I want to get you at. So I may not be able to go through the entire syllabus, and that I have to do a fast track with you guys. So I'm just gonna maybe just pinpoint some of the areas. But gonna have to go promise me. Next up, after the can I depend on the pair of you to work together, go through the questions that sir go now, and I'm still gonna work them out, and we don't have problems when I say to sir XYZ. I need a commitment from you.
Okay, funny enough, sir, I was gonna open my mic when you left to ask Nesta if it is okay, but I was a little bit afraid to ask her if it's okay for us to work together, because when I have somebody, the motivation, then I will push a little harder.
No man, Nesta is a cool dude. She cool man. She somewhat reserved, on the quiet side, but she cool. She cool them ways. So Nesta, can I get a commitment on?
Yes.
And you know Ottilie in person, right?
Really? Well, I've seen her, but we don't really talk.
Okay, so if you see her, you know her then, right?
Yes, sir.
All right, cool. So, I am just sitting here and I'm thinking to myself that I may have to be a bad teacher in order to get you guys to understand what is happening, because if it's a tone alone, I want to make sure I send a pass the stuff. I want to make sure I send a pass the stuff. All right, so I need to get your commitment. Once I have a commitment, I'm good to go. That's all I ask you for. Your commitment. So I'm sharing a screen. Let me tell you what my strategy is. And the only reason I'm taking this approach with the strategy is because it's a fast track class. I know Nesta would have gone through the entire course before at some point in time. Sure, upon Nesta. Hello. I don't know, auto leave would have gone through. It's about half the course or less than half, next auto.
Sorry, it was a less than a half. I just
Less
did
than a half.
like 3 classes or so.
All right, less than a half. All right. I'm going to be looking for the big boys.
So let me reach out to Chanel. Because I think Chanel was saying that she didn't get to do the exam.
And you are right. So that would be 6. Chanel Allison down.
Yeah,
Yeah, man,
I'm reach
you're right.
Sir Chanel will be in for next week, so I will update her
We'll
on
update
what was
her.
done. Yes.
All right, good. Why you hold her hands to here, because she's another one who is afraid. She start and she stop, and she start again and stop. So
I know, sir. We were in the same batch. We started together.
okay, cool.
Mhm.
All right, now. I'm going to be looking at the big boys. The different strategies I'm taking, different approach. A question like this comes from about 10 marks on the exam. Last time I only came for 11 marks. I am expecting to come for around about the same number of marks. And to get this piece of paper question or topic in one of the questions for 10 marks, and you can't do nothing more. At 10 marks you have so far. And if you go in and each question has one of those big boys. And if you go to one of the questions, and one of the questions, the big boy comes in out of 20 marks. So if you can manage a big boy for 20 marks, and manage a big boy for 10 marks, that's a 30 marks out of 60, you know. And so you go in the multiple choice and you panka and get 10. That's a 40 out of 80. That's a 50% for the exam. Once you get that, I mean, no longer pass in the editor stuff, and no longer pass in the mid-series, and pass the course. So this topic I want you to open up on the eyes and the ears and the mouth and the nose and focus on this. Big mark question. Are you back, Nestor? I was calling up on you. Nestor?
Yes, sir. Yes, sir.
Okay. So So that's what I want you to do. I'm going to project this drawing, this diagram, and then I'm going to ask you for your undivided. I'm going to have a conversation about that diagram. You should have this, my love.
Moving forward, if, well, maybe it would be unfair to say that. But sure, if we come a class and we get it right, like we know what we do, you can let you out, you can just end early.
What happened? You have a problem with the 5 to 9 on a Friday?
No?
What I'm saying, you have a problem with the 5 to 9 on a Friday?
Sorry, it's long, sir.
It's long? All right, don't worry about it. We'll find ways to get it. All right, so.
Mr. Member, the semester short, you know, so it's soon done.
Talk truth. But okay, next up. Look, it's because as I said before, there are a group of people who have been struggling with this course for the longest while, and I need to see you guys through. You have to promise me, next up, if you get it, I'll find ways of saying to you, do these pieces for me unsupervised, meaning outside of the session. So yes, I would give you, I could let you out early, but you know that a little later on, maybe on a Saturday, now you're going to do the extra pieces of work that I expect you to do. Is that okay?
Yes, sir.
All right. All right, let's go. So there is a crime. A crime. I don't even like talking about that crime now, because every time I think about it, I just get very upset. The Dr. Soldier guy that was murdered at his house. It is just it is just resting on me. I just feel caught up about it.
Yeah.
You know, we not have no love in our heart. We believe, say, my thing, my property is not mine, it's ours. And if you trying to steal my property and I say, hey, leave it alone, you just say, who are you to talk to me? And turn on and shoot me and kill me over my property that I've gone to school for. Look how Ono struggle with the calculus too. And I'm passing the calculus too, and then I get in a big job. And somebody just for come hold you and take away everything from Ono. It no fear. It no fear. And then worst case scenario, make me feel worse today. A teacher friend of mine, who I normally work with privately, today's her birthday. And I was talking to her about it, and she said, but you know him? Because when we were teaching at this place, he came there several times. I said, what you say? She said, yes. You may not remember him, but I knew him very well, and he was at that place. So I said, look at that. I just really feel it. I really feel it. But anyhow, I'm saying something to you. I'm saying to myself, let us be safe. Don't let the guards go. But in boy us our wicked. Right? So for example, there is a crime that is committed. Somebody witnessed that crime. And there are so many crimes taking place now. Schoolboy in Portmore get throat gets slashed and run out on the road, and people see him and they're in critical condition. young girl get throat gets flushed and she dead. Don't know. Mm. Anyhow, let me not use crime because I get very depressed. Let me. Anybody remember the situation? But then again, no, somebody died in that one, so I can't. All right, let me do this quickly and move on from it. Anybody remember the situation in the New Kingston region where somebody apparently was shot and killed on Old Hope Road, and then the getaway car was found by YMCA, and there was a shootout at YMCA some time ago?
Oh, yes. Yes, sir.
Okay, all right. So let me reference that situation. Since that one gone long time, I can't reference the ones that just went. So what would have happened is that somebody got shot on, and unfortunately it was a fatal shooting, got shot on Old Hope Road. And the getaway car drove in a particular direction. Now they were eyewitnesses to the shooting. They were eyewitnesses to the shooting. When the police was called, the police says, "Do you know where the car went?" He said, "Yes, man. The car go through Seymour. Go up on the road from Old Hope Road through Seymour." All right. The man who had taken the report on the line is able now to radio base and says a white getaway car. We don't have a license number, but the car is moving in another direction through Seymour. All units, make yourself available. And the man saying, policeman, them jumping in them car. Policeman, them say, all right, Matilda's Corner Police Station said, here the plan. We have 2 units. We're going to send 1 unit down on Hope Road. That is Old Hope Road. And then we have another unit we're going to send down on Hope Road. Hartford Police Station say, all right, we have 1 unit. We're going to send a unit there up Hope Road. Crossroads. So, you know, we have 1. We're going to send a unit there from Crossroads up to Old Hope Road. From Crossroads up to Old Hope Road. Then Stadium Police say, you know what? We're going to drive the trace. We'll leave from Stadium. We have to take Seymour, so we're going to drive behind the suspected route. So we have a series of police cars converging. Now, when I converge, it means that I'm getting closer and closer to something. When I diverge, it means that I'm going away from it. I'm diverging from the point. It means that I'm going away from the point. If I'm converging to the point, it means that every bit of movement, I'm getting closer and closer and closer and closer to this point. Am I clear right here?
Yes, sir.
One of the things though for the class.
Yes.
Right. Gonna have to keep me energized.
Yes, sir. I don't want to leave the mic open and you know unexpected night. So that's
No. I understand that. But I'm not suggesting that I want you to be very close and try not to multitask now, because again, I am going to be doing something different this season by getting the big boys out of the way and then with the small boys then afterwards, and not necessarily follow the sequence of the syllabus. All right. So the whole of the police carried my drive. All the police had carried my drive. And then now, them now get no closer, them now see on every unit, them say them now see nothing, them now see nothing. And one youth member said one name, JDS. And call the links. And JDS say apply. our car. And the eyewitnesses told them, what kind of make car? And I'm saying, no, so one axiom or white axiom. It no means say, it means say, them now go look for one black car, don't it? Or one red car or one blue car. Them look for one white car. Now, this is what is happening. When they intercepted that car on Trafalgar Road, the boy them alight out there and start fire shot. Start fire shot after the police. To the point where it became a laughing stock because one of the policemen was behind as much as the vehicle and was taking shade. Right? Two policemen, I think, got injured in that situation. But guess what? The point is that they were able to converge by sending units out from different points, converge until they bottleneck the criminals. Are you seeing that point? Can you visualize that?
Repeat.
No,
Yes, sir.
right. I'm just asking if you can visualize what it is that I'm saying. Mister?
No, sir.
All right. Utterly, you tell to get it.
So basically, you're just telling us strategies that they use to capture the person, forget the guys that they got the report that did a committed a crime.
Mm-hmm.
Yeah, basically
that's pretty much it. But what I'm saying to you is that I have different starting points for the other peeps. I have different starting points for the other peeps. So they are coming from different starting points and they are converging. So at least they can capture the person. Hold on 1 minute. All right. So I'm saying that the law enforcement officers are converging, meaning they're getting closer and closer to the getaway car. So next, the crime occurred at the crime occurred in Harvard. Of course, we didn't call the Harvard police station. But you know, say when the crime occurred, bad man do a crime and stand up. Bad man do the crime and run. So you know, say really no bad. So what I'm saying to you is, he's doing the crime and he's running. Where he runs is what we are interested in, so we can find it. So I'm saying to you, he's running. Where did he run? Did he run in the crossroads direction? Did he run up Constant Spring? Did he run up Old Hope Road? Did he run down to Hadley Park Road? There are several different roads. So let us say the man run down to Hadley Park Road. The first thing you're going to want to call Newport West, or maybe Harvard police station, near the plan Harvard. The man run down a Hadley Park Road now. So Harvard police station chasing go down Hadley Park Road. Once the police station now, our chase come up because since the crime happened 2 minutes ago, there is no way the man them can reach down 3 miles already. So 3 miles police are go come up, so they are converging on the dudes. And then they may have a Newport West. If in the go that way there, we would intercept him that way. And it happens. You're converging. Next, you see that point yet?
Yes, sir. I'm getting
All
now.
right. All right, good. So is you trying to find strategies to get closer and closer to the source, because we want to do is intercept the car, but arrest the man or the men to say, how kind of foolish is that? I eat that business to go on with. They go kill the man for. They'll go to jail. So that justice can be served. All right, look at that diagram. That diagram is exactly what it is that I just discussed. Exactly what I just discussed. Okay, sir, what did we discuss? Thank you for asking. Where is it? Look at the screen and look at my red dot. Can you see my red dot?
Yes, sir.
I am estimating. I'm estimating that to be my endpoint. I'm estimating that to be my endpoint. My answer. But guess what? It may not be. It may not be, because look here. I have this point. I'm estimating my endpoint. I have to draw a tangent. See the dotted line here? I have to draw a tangent to this point. Now this point that the cursor is at is a point on my graph. Is a point on my graph. So at the point on my graph, I'm going to pull something from here, draw my tangent here, and wherever the tangent hits this point is going to be my x2. I jumped over something here. This is my x1. My x1 is my initial guess. My x1 is always my initial guess. Sometimes I use x0 as your initial guess. That means x1 is going to be your first guess. Your first guess. Right? Give me your first guess. So I am doing this as my initial guess. At my x1 is at this point on my x-axis. I'm carrying it all the way up to the curve, touch it. I'm drawing a tangent to the line, to the point. The tangent to the point extends all the way down, come on, to the x-axis. What I'm doing, I'm drawing a vertical line from that tangent to back to the curve. Back to the curve. When I do that, I recognize that I'm getting closer. So this is where the initial crime took place. But based on me drawing the tangent to the stuff, I'm getting closer to a particular point. I'm drawing another tangent. See it here? Boom. All right. Now, wherever it cuts this point, and I'm going back up here, look at what happens. I'm drawing the tangent is going to touch yet another point. That point is going to be my x3 point. And I'm going to carry it all the way up to my vertical line until it touches the curve again. And again, I'm going to draw a tangent to the stuff. And when it's done, I'm going to draw a vertical line up. And then I recognize that I'm so close now to my exact root. So far I was all the way up f of x1. What do I want to do? I want to get close to my exact root. What is your exact root? My exact root will give me my solution. Does that make sense?
Yeah.
All right. And that's it. What I want you to do though is I want you to take about 2 minutes to look at the drawing, see if you can understand what it is that I'm saying or have said, and then we'll come back and look at the at a question. All right, so you can put it in practice. So take 2 minutes and just practice with it, please.
Okay.
You get it now? Let me know, you know. I'm waiting on you. I want you to look through the stuff. I want you to fully understand the stuff. Please don't just look at it and say, yes, sir. I want you to get it.
We start at 0.
We start at 0, right?
No, not at this 0.
The initial guess.
The initial guess is going to be x1, which is up here. So
At x1. Okay.
right.
Yeah, so that's me saying wrong. So you start at the initial guess.
Mhm.
That is the root of the equation, right?
You are trying to find the root of the equation.
Okay.
So the initial guess, I will keep making different guesses, is to take us to the root of the equation.
Take us to the root of the equation. Okay.
What is important is the tangent. You know, I keep saying to you that I keep drawing the tangent over and over and over. Because the tangent is the same thing as finding the differentiation. So when you're finding the tangent of something, we're actually differentiating something. So that's why it's important that we do the differentiation. Are you okay?
Yeah.
All right. So,
So this is the one you were doing when it is like it continued to iterate until you reach to where you want. Okay, okay.
Yes, ma'am. Yes, ma'am. Yes, ma'am. So Now that we find our, we get our initial guess. Sometimes the initial guess is given, sometimes we have to find it. Now that we have our initial guess is at x1. All right, our initial guess is at x1. What it means is, after I form my initial guess and do my stuff, I'm going to use this to draw my tangent this way. Drawing a tangent that way will result in a new vertical piece that is formed. And look here, so at this x2 here, this is where the tangent hits the x-axis. A vertical line drawn from the x-axis all the way back to the curve, will sit exactly on that line until that situation gets to another point where you draw the tangent, and wherever it touches the x-axis, you extrapolate. And when you extrapolate, you'll go back and you do the thing over and over. And that's the different iterations that Otley just spoke about. Fair enough?
Yes, sir.
Yeah.
So the numerical analysis, the Newton-Raphson method, named after Isaac Newton and Joseph Raphson, is a root-finding algorithm which provides necessary, successively better approximations to the root of a real valued function. All right? It says that it uses the idea that a continuous and differentiable function can be approximated by straight line tangents to it. Now, look at that. Tell me if you agree so far.
Yes, sir.
It says, it uses the idea that a continuous and differentiable function can be approximated by straight lines. All right. Let me do that one just yet. What I want you to do is, each of you, I want you to take, no, let me not give it that to do it. So I'm given a function, f of x is equal to x cubed minus 4x squared plus 1. And they ask me to approximate the root of that function. Boys, we wanted to approximate the root of that function. All right, here's the first iteration. The value for my first iteration. Oh, you have to go find it. But we can't do them something, yeah, man. So yeah, you have to go find it. Say, all right, no problem. What I'm going to do, there's no question to this. Here's an instruction to this question. So let me just highlight this point to you. You notice when I put 0 in the function in f of x, what value did I get out? Look at the pink one and see what value I got out. I put in 0, I got 1. I put in 0 and I got 1. When I put in 1, incidentally, these two ones are not the same. It's not this one here that I put right in here, so it's a different one. I move from 0 and then 1, and if 1 never work, I move on to 2. Very good. So when f of x is equal to 0, the function works out to be 1. When f of x is equal to 1, what the function works out to be?
-2.
All right. What do you notice between 1 and -2?
Yes, sir. What we noticed about it? Is to
So it's going down into the negative.
yeah, when the higher, yeah, the value you use, that's what I was gonna say. The higher the value is, it goes further to the negative.
All right. So what I want to hear you say is, sir, it changes from positive to negative.
Yeah.
Sir, one of them is positive. Then I want to know to negative, sir. That is what we hear. And I would say congratulations. Because let us go back to the drawing. You recognize that in my drawing, that everything here was positive, 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 until it reaches the exact root and it goes to negative. You see that?
Yes, sir.
Right. So whenever you have a change, whenever you have a change in the signs from being positive to negative, it suggests that you would have crossed over your exact root. So if you're using the values in sequence, like I'm doing there, 0, and then 1, and then the next one will be 2, and the other one will be 3, etc., etc. Once I change my signs from being positive to negative, or from being negative to positive, it means that I would have crossed over my exact root, and my exact root is near. So my exact root is going to be near down here. All right? So what I'm saying to you is that I would have crossed, come on, hold on. All right. So my write-up says you will see that between 0 and 1, the function would have crossed the x-axis. Oh, you know that, sir? See here? 1 is positive. So the positive is above the x-axis, and the negative is below the x-axis. Dark truth.
Yes, sir.
Watch me now.
Sir,
Yes, my love.
so this is always how we find the initial guess by
Yes, ma'am.
substituting. Okay.
Yeah. So if sometimes the questions give it to you. Sometimes the question gives it to you.
Okay.
But there are times you will have to work it. Hold on. Water break. So, yes, Nestor, every time they don't give you the initial value, you have to calculate the initial value that way. There are times, sometimes, they will give you the initial value. I say use this as this. There are other times they're not here. All right, so let's bear this in mind. Now, so we're going to note that we are guessing x1, which is my initial guess, as my first iteration. So why do we need a first iteration? When I tell a man them at control say, me see a crime, the first thing I'm going to ask him, sir, what is your location? Because while I'm speaking to you, and if you watch these overseas movies with scenarios like these, once you call 911 and the operator is having a conversation with you, that operator is actually typing the information as you speak. And the system automatically dispatches the information to those persons on the street. So while you're on the telephone with the dispatcher, the 911 operator, they're dispatching your officers out to come and give you assistance. It could be the fire brigade, it could be an ambulance, it could be a police department, wherever it is, the emergency response teams will be on their way. But one of the things I've been at, what is your location? And if it is that you don't know your location, they are going to be using GPS. When our computing students, when they know about pinging from the towers, they're going to say, okay, this call is being pinged from New Kingston. Let us go closer. We're in New Kingston. Boom, 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 boom. All right, this is Trafalgar Road. Just like when I'm going somewhere new in Jamaica here, I will go to my maps on my Google and I'll put in the information, and Google says my location is on. So Google will say to me, this is your location. And I can search my destination from just putting in where I'm going. I'm going to Smokehouse Ochi. I put in Smokehouse St. Anne rather. I put in my Smokehouse St. Anne, find a location, and I say start. What my system is going to tell me is going to give me the start point from where I'm at. So it gives you your location. All right. So that's exactly what that X1 is, my initial start, where may I move from. Now, it continues because there goes my Newton-Raphson method to do my calculation. I'm going to give you 2 minutes. You see how long I'm taking this? So this is a must-have. I'm going to give you 2 minutes, not only to write off this formula, but to see how it is that you can remember it. 2 minutes. I'm giving it 2 minutes, and I'm going to mute for those 2 minutes. 2 minutes, started now. Utterly.
Yes, sir.
Yeah. Do you have a number for Shani Smith?
Oh,
Shani?
Shani?
Yeah.
Yeah.
All right. So
Um,
she joined last week. You can message her for me, please, and tell her to come in now. I just remember her.
Shani. Shani?
That's what her name?
I hope I she, you know, I shot. Let me see.
No, man, I think that's Shani, she name. Shani Smith or something like so.
Shanie. It's Shani.
Okay.
I'm in a group with her. So
Hold on 1 minute.
okay.
All right. All right. Yes, see if we can get her. He said that Chanel said she was going to join next week, right?
Yes, sir.
All right, let me call it back. All right, cool. All right, no problem. All right, cool. Yeah, see if we can talk back. See if we can call her. See if we can call her from it being or message her. I don't know which one you have. But
Okay.
still look at the formula for me though in the meantime, right?
Yes, sir.
Cool. You too, Nestor. Shani, you got her? Sorry. Utterly, you got her?
Sorry, sir. I was talking to her. She come into class.
Nice.
Yeah.
Let me ask you a quick question while we wait on her. You seen the new money already, Utterly?
No, only for a picture.
Well, guess what? Me just get $1,000.
Okay. How is it?
To be honest with you, it looks better in hand than I saw on the picture. On picture, the Canada was crowded and ugly.
Oh.
The truth of the
It look
matter
like the Canadian money.
the Canadian money, exactly like the Canadian money.
Yeah.
The truth is, that it not look so bad. It really not look so bad at all. It not look bad, but it looks okay. I can say from what I see so far, me like it. It looks. I should see some phone. And coming on because for them the one them who are create them $1,000 Pascal was too long time. All right. So Nestor had stepped away briefly. So what I want you to recognize, because if I can go through this topic tonight and understand this topic, I'm going to some question and get the topic here. As soon as we get that topic here, I'm done class. If we get the topic in another 5 minutes, we're done class. You don't have to promise me though. I tell you now, what I'm doing, I am being a bad teacher for this summer because I want you guys to get through this course. So what I'm doing, I'm working with the big boys first. And forgive me for doing this, but I have to. I'm working with the big boys first. Get those out of the way, so at least you don't have enough time to work on mastering the skills of those big boys. And in Jesus' name, when you win on the exam, handle the big boys how they're supposed to be handled. Get the marks from them. That's all I'm asking you. All right.
Okay.
All right. So I forgot to use a formula here now. In order to do our calculations. X to the n plus 1 is going to be equals to x subscript n. You notice that I have the function up top and then the derivative of the function underneath. Yeah. So it's a function. When I marked the exam paper the other day, somebody made a mistake of putting the derivative up on top. No, it is the original function up on top first and then the derivative afterwards. The derivative comes in the denominator. Remember this. Derivative starts with D, denominator. The derivative is in the denominator. Just remember that one. The derivative is in the denominator. Please remember that. All right. Now, the second iteration is me finding the derivative of the function and substituting 0.5, which is my first iteration, in it. So what I'm going to be doing is this. My xn is my first iteration. C is going to be 0.5. Boom, 0.5. Minus f of 0.5 and f dash of 0.5. No, because I want you to remember what it is that is going to happen. I'm going to leave you to do something. I'm going to give you 4 minutes, 2 minutes each, that you can take your time and do it. You're going to substitute 0.5 into f of x and put down the answer and 10 minutes later. Then you're going to find the differential of this function, and then you can substitute 0.5 in there, and you're going to work it out and tell me the answer. Remember, you're going to do the work to make sure you understand it. You get what I'm asking you to do?
For the first part,
Right.
yeah, only the
Mhm.
first part.
Only the
So
first
you
part.
want
Right.
us to do the put 0.5 in the function first.
In the original function, yes.
Original function, which is the f of x,
Right.
and then you're asking us to do what's in the second part.
You're going to find the differential of this function now. You're going to find the
Okay.
differential of this function. Then when you find the differential of the function, you're going to substitute the same 0.5 in there. And
Okay.
then in order to get x, you can say 0.5 and set up with something like that one here. And then
Okay.
again, 10 we get for the answer. All right? I'm going to separate for 2 seconds, but I want you to work in the meantime. Next, Abu, you come back. I'm going to come back here. All right, go on work. You can tell her what to do when she comes at phone.
Okay.
What's that?
Mr. Abak?
I'm back, sir.
Sir, give us the question and answer. We should substitute it into the equation and do it.
Okay.
So him say we're gonna put 0.5 in the equation, eh? You understand, Alexa? Nestor?
Sorry, me talking my dear.
Okay. 0.5 minus 40, 0.5. So second plus x equal 0.5. Three. Minus 12.
Good evening, everybody.
Evening.
Mr. Shan.
He stepped away, Shane.
Oh, him already explained this.
Yeah, he went to went to it.
Oh.
No, I don't know much. I just not much.
Okay. Come here, look on the formula here and me I say, oh, this go.
Not much. Share with me. May I step away for just a small minute? Some come back.
All right.
Yes, my Jesus. All right, so but I get an answer now. What you got for f of 0.5? Nobody? Anybody? Somebody? Hello, somebody.
So the first iteration?
No, the first iteration is 0.5. What did you get for the second iteration?
Oh. So the first iteration is the initial guess now?
The first, yes, the first iteration is going to be the initial
Okay.
guess. Yes,
Okay.
yes.
No.
Very good observation. So the first iteration is going to be the initial guess.
So you have to do the decimal places.
Yes,
Or you
man.
can't run it
No,
off?
man. No. Okay.
Okay.
So this is a first example. So one of the things I'll say to you is that the questions will say, find the root to 3 decimal places or to 4 decimal places. Sometimes they may say to the nearest whole number, but accordingly you can work. But in this case, it's because we're doing this question, I think I may have used 4 decimal places if I'm not mistaken. So you use 4 decimal places. I think the answer, I wanted the answer in 3 decimal places. So use 4 or use 5. Tinker, you found f of 0.5 already? Let me just check to see how many decimal places. What do you got for f of 0.5?
Sir, really, please. Give me a second.
Mm-hmm.
I'm gonna put it back now.
Sir, stepped away. I said I was stepping away. I just came back. I don't know if you're going.
Oh, I was calling. I didn't hear you. I wasn't here when you said that. You got f of 0.5?
I found, I don't know if I was putting it in a calculator properly. 0.125.
I want to go for f dash of f dash of
I was supposed to do the next one. No. Oh, okay.
Yeah, man.
Let me just quickly put it in.
But remember, the other one is the first differential,
Oh, use the formula for the, okay.
So
X of 2.
let me know when I finish that one.
Okay.
Come on, hurry up.
Sir,
Hmm.
sir, for the second, the next one, I get 3.25, sir, but sir, I don't quite understand that though. I don't quite understand how you get that.
All right, no problem. So let us go. Just give me a minute, please, all of you. So this is a function that was given. That's a function. Now, if I ask you to find f of 0.5, the first iteration is 0.5. And we learned just now how to calculate the first iteration. All right? Now, having gotten our 0.5, anywhere in the original equation, in the first thing, we see x. We're putting 0.5. So this is 0.5 cubed, see it here, so minus 4 times 0.5 squared plus 1. This is a calculator action. This is a calculator action. You're going to have 0.5 cubes in the calculator, minus 4, open bracket, 0.5 squared plus 1. You should get 0.125. Try this one, please, all of you. All of you try that algorithm. You're going to open your parentheses, just as I have it here. Open your parentheses, 0.5, close your parentheses. Then you're going to put the upside down. Anybody know what that upside down V is called?
No, sir.
Upside down. Where?
Yeah, look on your calculator and you see an upside
Oh,
down
on the
V.
calculator. Oh.
Yeah.
Sir, me see what me do wrong. Put whenever something there. Put there. I put back the 2 instead of it's supposed to only be 1 for the second. So I would have 0.3 times 0.5 to the 2, and then I put back to 8, negative 8, 0.5 to the 2, and it's 1 because it's the first derivative. So I made a mistake right there.
I am trying to find the name of the upside down V again. I'm putting CERAT, and I won't tell you what come up. If you want to look on it, you can go look on it. I don't know why I think CERAT and something else come up. Curved. CERVAT. Curved.
Sorry, my calculator, may I look feet kind of just overcoded. When I find it now.
What? The upside down V?
Yeah.
No, which calculator are you using?
I have the Casio. F of X 9991 ES plus. Second edition.
No, you may have, it also says natural display.
Natural.
Yeah, you have the same one like
Lati.
Yeah. You're not gonna find an upside down V. You have good
It have a look at the X with the dot me for use.
Yeah. That you
Oh,
must
me
use.
just find it. Yeah. Fine.
Who else has one of those calculators with the upside down V?
Me, sir.
All right, yeah. Put all of that in the calculator, guys, and tell me what it is that you get, please.
Oh, Shani was saying, she never understands, so
She gone?
so we never do much. Don't think so. Look like
No,
we
no,
have other people here as well.
Oh, she keeps coming on and she's in and out. So I don't know if she has
And
internet.
Daniel is here as well. Okay.
Yeah.
All right, so 0.5.
So for the Newton-Raphson, I'm going to tell you straight up, it's not difficult. All you need to do is to know the formula. You just need to know the formula. You know how to differentiate the function, put it in another something, you're good to go. I kid you not.
So with my calculator, when we click, all right, so we cannot see the 2 here, so, but it'll give me some other stuff when we click on the X to the look at that, that give me other features. But maybe use the 2 for now, since I don't need to use a bigger number. 0.5. Yeah, I'm gonna get the negative 3.25.
You get negative 3.25? All right.
Yeah.
Okay, so for the first derivative, so when you differentiate the function, you got
I'm a
to
differentiate the
explain.
function now.
No man, you can't. No, the next is no. When it
No,
okay,
I got it, sir. I got the
okay,
second, the first zero.
okay, good. All right. What about the rest of you? Can you try it for me, please? You have to learn to put it in a calculator. I want you to try it, all of you.
Yes, sir, I got it. Shamoy, explain the next one.
Yeah, man, I will. But I just want to. I will. Remember, so this is all I'm spending time on for today, you know. So.
Oh, let me see. Remember the formula I said that tell we?
Talk to me. Let me hear what you guys thinking.
Sir,
Hello.
evening. I've got 0.464.
0.464. What is 0.464?
I worked out plugging the values in the formula. I got that value, 0.461.
I'm not following what it is that you're saying. Say it again.
All right, I used the formula and with the values.
Which formula? Are you talking about this formula here?
Yes, and the function and x1. But I'm saying that but x2 I got when I work it all out 0.461.
Oh, but I have 0.53585. That's what you're saying?
Right. So I'm wondering if it is incorrect.
You're wondering if it is what?
If it's incorrect.
Well, it would be incorrect because the correct answer is 0.5385. So do me a favor. Put in 0.5 for me.
Peter?
Put in 0.5 for me.
Yeah.
Minus. Open your parentheses.
Yeah.
0.125.
Yeah.
Divided by negative 3.25 and then a close the parentheses.
Okay. Yeah.
And then you press equal until what you get.
Yeah, I got the same thing.
All right. So your calculator is
That's stud mark.
oh, who is that again? But anyhow, it's not a real calculator brand. So you have to know, follow what I just showed you a while ago, so that in future when you're working your question on Newton-Raphson, you know exactly what you need to do.
Yes, sir. I see my error.
Miss Smith, can you unmute for me, please? Or she not? Shani?
So she named Shani.
A Shani, she name?
Mhm.
Shani, me always call her, she answer me. She tell us that Shani, she name?
Yes, sir. Shani, Shani. 0.538. All right, so teach that one day. Third iteration. Iteration.
Oh, Nesta, you say you got it right, Nesta?
Yes, sir.
All right. So, um, so we have that. So let me just point out something here. So we know what x1 was. X1 was our 0.5. So in order to find x2, we're going to put x1 into the formula in order to get x2. In order to get x3, we need to put x2 in it. In order to get x4, we need to put x3. So we have to work out one first in order to get the other one. Everybody see that makes sense, don't it?
Yes, sir. Yes, sir.
So therefore, if when you work out your x2 and it's incorrect, you're going to have an incorrect value to put in to get your x3. So it means that you're going to put your answers in a bit, out and further out. What's the point? I want you to take your time, be very systematic in your calculations so that you are not left out in terms of not getting the marks. Remember, I am doing things differently this summer. I don't want to sooner face into my calculus class again. I want sooner face again, but not in this calculus class. I want him to get it out and over with it. You have to work with me. You have to work with me. All right. So now that I got my x2 to be 0.5385, that is my x2 value. It is what it is now. Nestor, as you asked that you don't understand the third part. So the third iteration here, the third iteration is going to be where I'm going to, in order to find my x3, my third iteration, I'm going to put x2 into the functions. Remember, the function remains the same. It is a second iteration minus the original over the differential. So the original function, I am going to substitute f of the x2, my second iteration in the original function. And I already differentiated the functions. I know what the differential is, but what I'm going to substitute now is my 0.5385 into the differentiated function. So see, this is how it's supposed to look when I have the stuff. My 0.5385 minus f of 0.5385 over f dash of 0.5385. You must get a calculator that you understand how to manipulate in order to do your Newton-Raphson. All right. So I'm not going to show you how to do this because I want you to get a practice. The same way that we did this up here for x2, I want you to work this down here for x3. On your mark, set, go.
So I said we should work out the third iteration.
Mm-hmm.
Okay. It's fine.
Make sure all of you working in it.
Yes, sir. Sir, when I'm going to the third, right? It's giving me when I press my hold on, I'm gonna use the X. The X to the one, they can use that one, sir, and press shift. Sir, you hearing me? 0.5 7. One, 5, 6, 4. Plus 1. So I'm talking this one. I'm talking about negative 3.7 to negative 10, negative 3. So negative, negative 1 plus 1.
What were you saying, Natalie?
I was trying to use the function, the x to the block at the top, but I saw I get the answer. The 0.5385, I got it to be 0.1562.
Which one? The 0.5385 I got it to be what?
To the third, 0.1562.
No, sorry, not following you. Which one are you doing? The third iteration or the second iteration?
Third one.
The third iteration, okay. Explain the 0.621 to me now. What are you saying?
The 0.55385 to the third. When I put it in my calculator and I use that feature, I got 0.1562.
All right. To the minus 4 times 0.5385 squared plus 1 and 10 if you get those answers that I have projected.
Oh, you put up one.
The rest of you in the class,
Say
did you get that?
Say
it again?
Nothing is showing.
I forgot. I got kicked out and then it came back. You're right.
So I get 1.1599 plus 1. When put in my calculator, be a full 50. All right, so I'm gonna get 0.5 for the third. So, oh yeah, that's putting everything one time. Can I work it out different? So I may get 1 point. I'm gonna get the answer there. That's
what I want to try.
So a 1 minus 1.1599 equal to 0.1. Still not get the answer there.
All right.
So may I do something wrong?
No, you hold on because your calculator is supposed to be able to give you your answer one shot. So do me a favor, open your parentheses on me.
Yeah.
0.5385, close the parentheses. Let me know when to close it.
Yeah.
All right.
Hold on, so put something extra. All right, go ahead now.
Look at the you see where you say X with a dot beside it? Press it for me, please. And then put in 3.
Yeah. Then
press minus.
Okay.
Tell me if that minus come up top or is is to the side of it.
It don't bracket for the 3, so the little upside down V, and then you open a bracket for the 3.
Okay. All right. Press a minus now 4.
Because we have minus 4. Okay.
And then you open a parenthesis now.
Open parenthesis.
And then
0.5.
Yeah. And then press the same X to the something and put 2 squared. Close the parenthesis and do that. And then put plus 1 and tell me what to get.
0.17. 2, 4, 0.
All right. Maybe my answer is wrong then. The rest of you, I want to do that. What it is that I was working with?
Sir, me not get that to true, sir.
All right. What are you getting? Are you getting what Autumn is getting?
Wait, let me read it. Sir, me not get the 0, 0 then. Go 1, 0. Wait, I'm not telling you.
It's okay for the for it to be on start the mode.
It should be fine.
Okay. Go again. 1, 3.
Sir, me get
4,
for the first one, I get negative 3.774.
4.
I got the same answer, but if your calculator is at the end, multiply by 10 and negative 0.3, and it's supposed to be about like 3 zeros.
Okay, no, because your calculator is supposed to be saying 3.774 times 10 to the negative 3.
Sir, work it out individually and tell me what you got for the first parentheses. When you raise them to the third
Yes,
power
sir.
of the first one.
I never even thought of that, you know. So you're getting 3.774 times 10 to the negative 3, Nestor?
Yes, sir.
Yeah, that's the same thing. That's the same answer as I have on the screen.
Sir,
It's just that it's in standard form.
okay, I didn't know that.
But why am I getting a negative? Anybody getting a negative?
Yes, sir. Negative, me get negative 3 point whatever.
But you know, it says positive, me have my answer there. It's positive, me have don't.
Yeah.
It's supposed to be a negative.
So it should be a negative, so it should be a positive.
It should be negative, right, Daniel?
Yes, sir.
Positive.
It's supposed to be positive?
Sorry, negative me have.
All right,
Sir, it's positive. It's positive. You should have it.
All right, check it again for me. All of you check it again for me, please, because I just checked it a while ago and I saw a negative answer there.
There's a negative me get, sir.
All right, cool. I want all of you to check it for me so that I know that I'm on the right track.
Sir, so like all mine say doesn't like all mine doesn't have the 0, 0 in front of it. If I put what I had here, would it be wrong? Or would it be the same thing?
It wouldn't be wrong, you know, but to say what I'm thinking about now is if you're to find the fourth iteration,
yes, sir.
How would you input all of that in a calculator? Do you know how to use the exponential function on the calculator? Is what I'm concerned about now. Honestly. And it's not just you, but for the others too. So that's where my concern is.
Oh, sir, my calculator show me negative 3.7 times 10 to the, what do you call it, negative 3, whatever.
Yeah. Daniel, check yours for me again, Daniel, please.
Oh, so that means a 3 0 in front of it. That's what 2 0 in front of it because it's a 10 to the negative. Okay, right. So we get a negative, man, a negative. So it'll be negative 0, it will be 0.0037. Oh my god, no, 74. I forgot to run it after 8, 3, 8. We're running it after 3, 8, that's fine. Or 3, 7, sorry, because
yeah, man, no, yeah.
0.07. Okay.
The question will tell you how many decimal places to use.
Okay.
Then I'm waiting on you to just double check.
Sir, how much change my calculator from giving me this and giving me the exact figure? Or is it because I put everything in the calculator one time?
No, it's just because my one come well, no.
I'm gonna change the mode and see if it will. to the side. Oh, it's me changing more than it work that we have correct way now. -4. Okay.
Then I'm waiting on you to double check for me, please, to make sure that you get a negative.
So I get 0.003774.
And you get a positive?
That's a negative.
You say negative sign there, yeah. So I left off my negative sign.
All right.
All right. So yeah. So I have to go over my question now because mine didn't have the my f dash of x never had a negative 0 point. Oh no, I'm correct.
Yes, sir. David.
I'm correct. Yeah.
Sorry, when me when me go back going in the mode, when me get back down to the from the power part, what do I press? But change the mode and everything again a power now.
Actually, you're the lonesome tonight. I have no clue. I have absolutely no clue.
We're gonna figure it out.
You have a menu button on your calculator?
No, a menu. Hold on. No.
You can't help it. Shani is having difficulty. She's in and out and in and out.
Open number 60. Oh, my figure it out. Just use the little 4 arrow them. And just go down. Just press the down arrow and the bottom one and we go back there.
Better you than me. 0.5385. So here, let me make one careless mistake. Look at my X3. Don't you see my negative sign down here for the X3?
Yes, sir.
Extreme.
That's
Yeah.
So I have it. So I left it up here, so but I had it down here. All right, so I'm correct then. All right. So did you get your X3 to be 0.5374? Anybody?
Huh?
Did any one of you get the X3 value, the final value for X3 to be 0.5374?
Oh, I'm plug it in. I never plug it in. Come in there, appear on the calculator. All right, so sorry, now it show me -3. What is that? X. The calculator, I give me a foolishness. Minus 0.00377.
yes, sir.
Very nice. Very nice. What about Mrs. Shani for me, please? Okay. Our microphone is finally up. Can you unmute for me, please?
Okay.
Miss Smith? From this area. Oh, you say shame, no? Oh, Jesus. I want to make sure there's not the topic don't you know the problem I have using the calculator. Talk truth.
Yes, sir.
There's nothing wrong with the topic. Topic done. On a can't use on the calculator.
There more on next example, sir.
No
But
man,
more something will completely different from all this look.
absolutely.
Because sometimes me, you see if me practice something and it now look the same, me get it wrong. So more something different completely, so me see if I understand the truth.
No problem. I just want everybody to tell me that them on the same page with me, so I can wrap up this one and then project a new one.
Yes, sir.
Daniel?
Sir, I got the answer. The same 0.5373.
All right. Watch this now. I said because the values are so close, there's no need for another iteration. Right? We don't need for another iteration. What do you mean by the value so close? This x2, x3 is 0.5374. And the second iteration is 0.5385. So clearly, they would have asked me to 2 decimal places, because when I round this off to 2 decimal places, I'll get 0.54. And when I round off this to 2 decimal places, I get 0.54. If it was 3 decimal places, that would not work, because 3 decimal places, this would be 0.539, and to 3 decimal places is 0.537. So clearly, this question had asked for 2 decimal places. All right. See a question there for 15 marks. So this is what Nestor just asked. So let me just help you out with the first line. The question said, given the equation x cubed equals 2 minus 2x, show that the equation has a root in the interval 0, 1. Nestor, you say this one, no, them tell you what where the interval is. In the first one, they never give it where the interval is. But in this one, they told you where the interval is. Them say they want the root to lie between 0 and 1. What this means is that my answer is going to be a value that is between 0 and 1. So I can't get my answer to be 1 point something. Neither can I get my answer to be 0 point something. My answer must be 0 point something, 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 because it says that the interval, the root of the equation, lies between 0 and 1. So I need to find the other 2 roots. Hence, find the root of the 2 decimal places. So this one now asks me to find the root of 2 decimal places. So since the question said to find the root in 2 decimal places, I cannot work in 2 decimal places. I will have to work in 3 or 4 decimal places. Now, the practice that I use, if they ask me for 2 decimal places, I'm going to work in 4 decimal places. I always work in 2 more decimal places than they ask me for. If they're asking for 5 decimal places, I'm going to work in 7. If they're asking for 8, I'm going to work in 10. Right? When I do this, I know that I'm not throwing away any values. All right? So they can't ask you for 3, and you work in 3 decimal places. That'll go wrong. Straight up. All right? Now it says, given that the equation x cubed equals 2x minus 2x, what I'm going to do is to transpose that equation. See, given that function, I'm going to transpose it and let it be equals to 0. So I'm rearranging the function. So I'm rearranging the function to give me x squared minus 2x plus 2x equals 0. Look to see if you agree that I'm able to move from this step to this step, and tell me what you think. If I did a transposition there, instead of having the equal sign in the middle, I put the equal sign at the end.
So yeah, let's add the 2x.
So you're going to send the documents? I'm gonna just write the question.
I definitely will. I definitely will. But I want you to, as I normally do, I want you to agree with me though before you move on that that is true. That is arranging the x cubed minus 2x plus 2x is the same thing as the one that I have on top. Agree with me.
Oh, yeah. Okay. When I equate it to 0, yeah,
All right. Now, so Nestor, so that is another question in another form. But because I'm showing it in that other form, I have to give you a little pricks as to how to transpose. Now that you know how to transpose it, what I want you to do for me is try as best as possible to do that question for me. Let me go back up to the point there so you can see what is being asked of you. And let me just show you something here, Nestor. There's another thing. It's when they give you the interval, when they give you the interval, when they give you the interval, the interval says 0, 1. The interval says 0, 1. 0, 1. It means that you're going to add the lower limit to the upper limit and divide it by 2. You're going to do the lower limit plus the upper limit divided by 2. So it's going to be 0, which is the lower limit, plus the upper limit, which is 1, and 0 plus 1 is 1, and you always divide it by 2. 1 divided by 2 is going to be a half. So it means that my first iteration is going to be 0.5. My first iteration is going to be 0.5. So that's another method, Nestor. You notice the first one, what Sarah did was to play around and substitute 0, then look at the value that he got, then substitute 1, then look at the value that we got, and then because both values were different signs, it told me that I have a root that lies between 0 and 1. In this here case, them now ask if we go to them fan down to something there. Them I tell you say straight up, say here the plan, ropes. I have one function x squared equals 2 minus 2x. And the root of the equation lies between 0 and 1. Find the exact number for me, please. And the number is supposed to be 2 decimal places. That is the answer. Start with this. Same thing like we did before now. So I have unraveled those two parts for you. So now you're at the same point where I was at the first question. Start from it, please. When you not gonna sleep on me?
No, sir.
Okay, cool.
No, sir.
Hello. When I know seven o'clock when like when I talk to me, and then answer me.
Yes, sir.
Sure, answer me now.
Sir, I'm gonna know what I'm going with this, you know. It'll give me be a fraction. I can't bother with that calculator.
Oh, fraction, just press S to D or F to T, F to D, S to D or F to D to convert it from the fraction because it's natural display calculator, so it will give you the fractional form. You see the F to D or S to D button? F to D. F with, let me see what my one is.
Two look that's two look something.
F with an arrow and then it's a D on the other side. Or you may see S as in shand to D. So it's like standard to decimal or fraction to decimal. No, yeah. Check.
Yes, sir.
Right, so
Okay.
Okay.
for the answer, I got 0.8182.
Why that sound like it's right, sir?
Yeah.
Yeah, man, that's X2. Very good. 0.818. And remember, the after two decimal places, I'm going to work in 4. But I was going to ask a question. Everybody okay with that?
Yes, sir.
Nice job. Anybody not getting that so far? Do me a favor now. Calculate X3. Calculate X3 for me, please, and tell me what to get. Good job.
So my calculator, my biggest problem in our head.
Me know, sir, the topic of the calculator.
I look for the F to D where I tell me, and I cannot find it all now.
Take a picture of the front of the calculator and send it to me, please.
Okay.
Matter of fact, somebody need to create a WhatsApp group for this class.
Think we could do it.
Yeah, man, and then you can make people join it by the link. And the clear throat, you know, so they not sleep.
So I'm gonna get 0.7722 or 23 if you don't know.
Very good, Mr. Boo. Very, very, very good, Mr. Boo. So come in, we can do the work, you know. Again, beat you. And that's a threat. Can do the work. Excellent, Nestor. Excellent. Anything you eat for lunch today, go back and eat it for the rest of the days. Very nice, my love. You recognize that those values are off because Daniel said that he got 0.818 and now you're getting 0.7223. So you have to go do another one because those values don't correspond. Remember, you end with or Newton-Raphson when the values are the same. You get me?
Okay. And send the link in the group. We can just click on it and.
Good job. Thank you, my love. All right. So go ahead now. All of you go ahead and calculate the fourth iteration, please. Good job, next.
Sorry, may I put in the group and see my calculator?
No problem. Oh, let me go and join.
Sorry, I already add you.
Okay, good. Hello, lady. So as we look on the calculator, we see the STD. Look over the delete button, the DEL button over the green one, the button above it is it.
Oh, I was looking for FD.
That's what I said. F to D or S to D.
No, I was looking for F as in Frank and D as in dog.
Right, but I was saying is one of two. It's either F to D or S to D.
Oh, whenever I hear the S. All right, cool.
So just press it now. Press it now, and it should convert from the fraction to the decimal. Finish?
Yes, sir.
What's the answer?
I get 0.7709.
0.7709. Joe, you're going wicked tonight. How many
Sir,
decimal? Huh?
Sir, when I realize, sir, I have to go slow. Because sometimes you miss maybe the decimal or you miss something.
And that's fine. So guess what? What I want you to do next of all, if you like this, you like what you find in a rhythm here, continue working with that rhythm. So if you slow your upper go, one slow. You found the rhythm, work with that rhythm there.
So I have a question, bro. So for like the second,
Iteration.
no. What do you think of the F with the little slash?
The first derivative? The derivative?
Yes, sir. Sir, so comparing to the first one, so the something I have in red was said 3x squared plus 2.
Is that what?
Hmm?
What about it?
Sir, how you know say additive put?
Because that's the differentiation of the function. The function that was given, the function is x cubed minus 3x minus 4. No, lie, that's not the function. The function is x cubed minus 2x plus 2x. X cubed minus 2 plus 2x. When I differentiate x cubed, I'm going to get 3x squared. When I differentiate negative 2, I get 0. And when I differentiate 2x, I get 2.
Okay.
So that's why I
Okay.
get this here. So I have to differentiate it. All right, so I did a fifth iteration. I did a fourth iteration. And the fourth iteration is at 0.7709. All right, so let's just look at the third iteration and the fourth iteration. How many decimal places they asked us to do? 2 decimal places?
Not sure.
We did
Yeah,
say
two
two
decimal.
decimal places. All right. So we did 4 iterations. Now I'm going to give you an extra piece of exercise in this question. You know that the fourth iteration, if you look at the third iteration, you got 0.7723. So this the 2 decimal places is 0.77. The fourth iteration to 2 decimal places is also 0.77. So you can end to say that the value is 0.77. But I want you to find the 5th iteration to confirm that this 4th iteration is correct. So do one more for me, please. Do one more and find the 5th iteration. And if your 4th iteration is correct, the 5th iteration is supposed to come out to be the same thing. So do one more iteration for me. Yes, you have to take your time and do it. It means you have to take your time and do it next. Don't rush it. 1 minute. Answer? You
Got the same thing, sir.
All right, you must get the answer by now. What is the answer?
Sir, I got about the same thing, sir.
Very good.
Same one,
Ex-
sir. Yeah.
Very good. Very good. So let me show you that you're correct. You'll get back the same 7709. So you know that the answer is there. And that's the correct answer. You know that's the correct answer. All right, so let me pause it right here now and ask you a question. What do you think is the most challenging thing about the topic? Do you think you're understanding it? What do you think is preventing you from understanding it? I want to hear from each of you. It's not a whole lot of us in class. Tell me where it is that you are struggling so that I can see if I can help you. When I hear from all of you, I'm going to answer your questions. Then I'm going to give you one more to do and see if that would have cleared up your issues. Go ahead, anybody, somebody.
Sir, so far, I'm gonna say issue with it, sir.
Mhm.
You just have to take time because, like, when I do it first and I get an answer and I do it again, sometimes I get a different one. In terms of putting it in the calculator and all that, some realize you have to take time because sometimes you will miss. If you miss the slightest thing, obviously everything I'm saying. But apart from that, it's okay. Like, I don't see any challenge.
Very good, thanks. And I'm proud of you for tonight, incidentally. Very nice. Really, really proud of you. All right, next.
Sir, all right. So as necessary, I have to take your time because I have to figure out. It's gonna take a lot more practice to really get it without going back and looking at the steps you're doing each iteration. So it's just to say, I can't, like, if you give one question now, I can't write it, but I can't do it by myself without going back and look on the iterations. I think it's more practice that I would want to learn the different steps.
And that is okay. Remember, you're learning this for the first time. It's not a problem. If you have to look back, that's not a problem. But while you're looking back, try to put it to long-term memory so that you can remember the steps. But
Yeah.
fair enough. Proud of what it is that you're doing. Are you finding any other difficulty other than just taking your time?
No, just was the calculator, but me figure
The
it out.
calculator, yeah, man. Yeah.
Kind of as me go along, I take time.
Fair enough. Next.
All right, sir. I share the same sentiment. So I need to take my time because sometimes what I find out is that I would leave out the sign if it's positive or it's negative. And really need to take my time, especially for the differential fraction for the denominator. Need to watch that one so I can get the proper answer.
And remember also that you have to differentiate the function. Make sure so you differentiate the function. Make sure that your differential of the function is correct. Now, next, Ms. Smith, can you speak? All right. Make sure that the differential of your function is correct. If the differential is incorrect, you're going to be posing a lot of issues. Now, if the question says to you, do 2 more iterations, do 3 iterations, or 4 iterations, and when you reach the 4th iteration, you're not seeing anything converging, And converging meaning that, as I said to you in the example, coming together, it means there's something wrong. I have to start the question again. It means there's something wrong. If when you do, you notice when we do the question, somebody got, Daniel first said that, sir, I got 0.8181. I said, okay, great. Then when Nesta said, sir, but I got 0.7723 or something like that. And she did it and said, but sir, this time I got 0.7709. I said, try it one more time. And she got the 0.7709, right? So if when she did it when she did it that fourth time, and she got back like 0.8 something or a value that is not looking close to the answer, meaning you know, as close as to the 2 decimal places, you know something is wrong. You know something is wrong. The question always converges. The question always converges. If it is that you can find the root, estimate it using the iteration. Topic done. But Miss Smith is not hearing me. I don't know if she's hearing but can't speak, but calling upon her and she's not responding. All right. Do me a favor. This one is to tell me if you fully understand. Example 3, I'm not explaining anything in this one. I want you to read it and try this on your own. Read this one and try this one on your own. Numero 3. Number 3. On the market go. No man, I'm supposed to finish by now. I don't hear nobody even taking a good breath or a good sigh.
Over there. Sorry. Alright, so the here. So may I get some number? First one me
Okay.
get so I'm gonna get it like a 0 point something them. The first one me get was like let's see a 2.
You get a 2.
So yeah.
No, remember 2 is the first approximation. You know?
So I some for use a 2 in this. Negative 2, I don't know where. I do it right. So negative, not 2, sir, negative 2. For the, and then I do, I substitute it, and then I get, for the
I'm
first
sorry, it's a negative 2. You can't get negative 2.
I don't matter. All right.
You know why? Look at the first line. It says it has a root alpha between 1 and 3. So whatever root you get lies between 1 and 3. Negative 2 is not one of negative 2 is not anywhere near there. So
So you're talking about what, the first iteration?
no, the first iteration is 2. They gave it the first iteration to be 2.
2. Right, and then the
And
second.
even if they never give you the first iteration to be 2, remember the something say it lies between 1 and 3. So you again add 1 to 3 to give you 4. 1 plus 3 is 4. 4 divided by 2 is 2. So if the lower limit is 2, 1, and the upper limit is 3, it is a student I need to come. Is anybody in class with?
Sorry, I'm trying to work it. So let me see
I'm not. I'm going to give you time to work it, but another student comes to mind. Anybody in class with? Kelvita?
No, I haven't seen her. No. We probably can't find one number for her.
Please, and if you do, just drop it in the give me a number for her, please. She has been on my mind, and I need to touch base. Please.
Okay.
Go on, work it. Go on, work.
All right. So this is what I mean.
sir.
Yeah.
When I get for the second iteration, can I get some two? Only part two something. So.
Well,
2
for the third iteration, I got 2.1
9,
96.
6. Yeah, me get that for this third. Oh, that means you're right then. So that correct?
Yes, ma'am.
I'm good too. Okay, come with that, Fred. So me I do something more. Let's see it. There is a substitute. The fourth iteration. Instead of 4.
That's the one for the third iteration. It's talking about 2.1962, right?
Yes, sir. Working the fourth one.
Good job.
0.1962. All right, and then 2.162 divided by 1, 2.162.
What's the fourth iteration?
Wait, may I finish up? 2.1962 minus first one make it 0.0042. I got put another one there. Then I got divided on the second one. So 11. But I get 2.195. Very same to this. So, all right. This has a 2.1962, 2.19. So it is the near door.
Look at the screen.
Oh,
You need to work on your self-confidence.
okay.
And then to how many decimal places the question answer again?
Let me go look, sir. 3 decimal places.
What is the answer?
3 decimal. So we're gonna say 2.196.
2.196.
Okay.
That's the end of the question.
Because the next one was 2.1. Okay. Then near. 196.
All right, you guys did well.
Need enough practice.
And that's exactly what I was going to say. You understand what features are supposed to be doing. You just need some practice. All right.
I'm going to sort out this stuff soon off to you. Just be good and be safe. Thanks for coming out and continue working hard.
Okay,
All right.
thanks, sir. Thank you so
Yeah,
much.
cool.